Hello everyone, I'm Jeremiah Wong and welcome to the Frontier Precision Unmanned Education Extravaganza. In this video we are going to go over mission planning for the DJI L1 LiDAR payload on Matrice 300 in UGCS. So let's start. So in UGCS, this is generally the screen that pops up when you start it up. You want to make sure it's up to date. This is the version that's up to date at this point in time. Um, I'm going to map this area right here. So the first thing I'm going to do is I'm going to add a new route. You can name it whatever you want, or you can import a KML, line string, what have you. But I'm just going to click next. I'll choose the DJI Matrice 300 RTK. And then this right here, this kind of depends on what you're doing and in the environment you're flying. Uh, in general, I'll have the aerodome zones and the custom zones still activated. For mission planning purposes, my maximum above altitude above ground is something ridiculous. Um, Action on loss of RC, it will come home. I'm not doing anything below or on top of my intended surface that I'm mapping, really. Um, and in terms of return to home, usually I'll raise this up because for return to home, there is no terrain following. So try not to fly behind a hill and hit return to home because there's a good chance you might crash into the side of the hill or mountain or what have you. So for this one, I'm going to put 80 for 80 meters. I'm going to click OK. So the first thing we're going to do, I usually don't set a waypoint first, but what I'll do is I will set a takeoff point, which is going to be probably where I'm going to take off, which I am guessing will be right there. For this, I'm going to tell it to take off and go to an altitude of 80 meters. It's going to take off at and fly to that 80 meters at about 5 meters a second. The next thing we're going to do is we're going to go here and click LiDAR area, and then I'm going to click around the area that we're going to fly. So we double click, double click, double click, double click, double click, and then we right click. So when we right click, it ends that command, and then now it starts building the mission right here. Um, so one thing we do have to do though is to ensure that the camera works. So right now the LiDAR sensor should automatically trigger. So if I go zoom into, hopefully thinking, yes, waypoint 2 right here, you'll see that L with the power symbol in there under terrain elevation. That's saying it's going to trigger the LiDAR unit to go on. But that doesn't necessarily mean the camera is going to trigger too. So what we're going to have to do with that is we're going to have to tell it the camera to trigger by time. So you just click this button right here, and then you just leave it at auto, so it'll automatically do it by itself. And the camera should trigger now, all by itself too. For here, for set camera altitude, this is just telling it to tilt the camera or the L1 payload down 90 degrees, so it's facing straight down to the ground. So let's zoom a little bit further back out. All right. So over on the left here, we have a bunch of settings. I'll go over most of them. But the first one would be FOV, or field of view in degrees. So the L1 payload is a Livox Avia sensor, and that sensor has a 70.4 degree field of view. So I just put in 70.4. Altitude mode is going to be above ground level. And then my flight altitude, let's say, will be 70 meters. In general, we like a little buffer and a little bit more points on the ground. So we generally fly at 50% overlap. That's what we recommend to all our customers, and that's pretty much all we fly is 50% overlap. In terms of flight speed, this again depends on the situation you're in. If you're going to be flying something that's kind of like this and more or less bare earth deal and not really much foliage and things like that, you can fly a little bit faster because more points on the ground is always good. but you really don't need a ton of points if you don't really need to penetrate like trees and things like that. So for something like this, I mean, I'd fly at maybe 10, 12 meters a second, and that should be pretty good. Um, Down here under camera, so when you do this, you want to make sure you have the 4.3 sensor for the L1 picked. Forward overlap is good. I mean, you can turn this up, it won't really change too much. Um, so the photos that are taken from the L1 are not necessarily supposed to be used for photogrammetry. It really is only supposed to be used for colorizing the point cloud. So keep that in mind. If you want photogrammetry, if you want to generate an orthomosaic out of this, I would still go through and refly the mission specifically just for photogrammetry. Um, but for my forward overlap, I'm just going to put 70% down. Because for photogrammetry and generally everything, I kind of just like more photos. So this is more of a personal preference kind of thing. You can dig a little bit deeper into it too. Um, you might find, a couple other settings might work better for you. Um, the next one is direction angle. This is just changes pretty much exactly what I'm doing now, the direction that the flight lines are going to go. You can see the numbers changing when I do this. I don't really like flying it. I like kind of flying parallel to the side of the mountain instead of perpendicular going straight up when I fly missions like this. So the next one after that is double grid. I mean, if it's really complicated and heavy foliage terrain, I mean, you could more than likely, I mean, you could definitely fly a double grid. It's more data, the better. If time makes it so that you are able to do it, you could definitely fly a double grid. For most cases, you don't really need to. But then again, it is a case by case thing. Most things you can just get away with a single grid. Um, these right here, I mean, it really depends on you too. Loop angle, so if you do something like 90 degrees, so they put this, I think they put this in the UGCS. Uh, but for the most part, these just control how it swings around in the corners. Um, Loop train angle 90, corner radius 10, 60, 25. So, I mean, in general, you can play around with it and get it the way you like it. Um, Overshoot speed is how fast it can overshoot the speed that you have set to fly. So I have it set to that 12 meters a second. You kind of leave these generally where they are. Um, but besides that, after you have all your settings, after you have all your area the way you like it, you can even go through and you want to get this right here too, but I didn't quite do that. You can just drag and drop it and drag it out and drag this one out, and it will recalculate the mission. So that's good to go. And then the last thing we're going to want to do is we're going to set our landing point, and I'm going to set it pretty much right next to where we took off, and then now it's going to take that into account too. But note, it does not do terrain following to and from. Return to home. So make sure you keep note of that. In general, in a situation like this, if I'm flying up and I know there's a lot of trees, I mean, and I'm flying on the other side of a hill, which is generally something you're not supposed to do or not really want to do. It's not the smart thing to do. Um, but for something like this, if the mission ends over here and I know it ends over here, I'm going to end up taking control over it, and then I'm going to also be monitoring it too. Um, but besides that, this is how you plan a mission in UGCS for the M300 and the DJI L1 payload. If you have any questions, you can always reach out to me, Jeremiah Wong, or you can reach out to us at Frontier Unmanned at UAS@frontierprecision.com. Again, hopefully this helped you out, and I'll talk to you guys later.